Okay, so here we are discussing the NEET mock test 7. Okay, so let's go to the question number 1. In the question number first, we have asked what is the dimensional formula of 1 upon mu naught epsilon naught. That we have to find out. Now we know that the speed of light c is 1 upon under root mu naught epsilon naught. So c square will become 1 upon mu naught epsilon naught. So 1 upon mu naught epsilon naught will have the dimension of c square. So dimension of c square will be, as c is the speed of light, so its dimension will be L1 t to the power minus 1. So its square will become L to the power 2 t minus 2. So B option will be correct answer in this situation. Okay. Now let's go to the next question. The second question. In the second question, we have given an equilateral prism is made of a material of refractive index root. So as it is equilateral prisms, A will be 60 degree. Mu we have given is to find angle of incidence for minimum deviation for the light of the light. So we know that for minimum deviation, R1 will be equals to R2. Let's say it is R. And we know that R1 plus R2 is equals to A. So R plus R will be equals to 60 and R comes out to be equals to 30 degree. Now we can apply Snell's law. Mu1 sin I is equals to mu2 sin R, right? Mu1 we have is 1 because it is placed in air. I we have to find out mu2 is root 2 we have given and R we have got is 30 degrees. So that will be root 2 sin 30 is 1 by 2 that we know. That comes out to be 1 by root. So I comes out to be 45 degree, right? So D option will be correct in this situation. Got it? Now let's go to the next question. The third question. In the third question, we have given a disk of mass m and radius 2 meter is hinged, keeping x horizontal. If angular acceleration of disk is 2 radian per second square, then find its moment of inertia. Okay, so this is the situation we have given something like this. F we have given is 10 Newton and its radius we have given is 2 meter. Now torque we know is I alpha. So torque of this force into 2 is equals to I into alpha we have given is 2. So I comes out to be 10 kg meter square. So A option is absolutely correct in this situation. Okay, now let's go to the next question. In the next question, the fourth question, we have given the figure shows a plate of a parallel plate cathode with a separation of 10 centimeter charged to a potential difference V. Find the potential difference between B and A. Okay, so first we will draw the situation. This situation is something like this we have given. So this will be its situation, something like this. So this is 3 centimeter and this is 4 centimeter we have given. This is A, this is B, and this is 10 centimeter. So if the electric field between the plates is E, so for the potential difference between two plates, it will be like V is equals to ED. So that we can write E into 10 because the distance between them is 10 centimeters. It will be 10. Now we have to find potential difference between B and A. So VB minus VA we can write A into 4 because the horizontal distance between A and B is 4. So in place of E we can write V by 10 into 4. So that comes out to be VB minus VA comes out to be 2V by 5. That will be 2V by 5. So A option is absolutely true in this situation. Okay. Now let's go to the next question. The fifth question we have given in the fifth question, binding energy per nucleon in 1H2 is X and for 2He4 it is Y. So binding energy for this we can write is 2 into X because the X was given binding energy per nucleon. So this will be 2X and for 2He4 it is given as Y. So binding energy for He we can write is 4 into Y because its mass number is 4. Okay, so in the given reaction 1H2 plus 1H2 gives 2He4. The energy released, it will be equals to 4 y minus 2x plus 2x. So that will be minus 4x plus 4y. So B option, which says minus 4x plus 4y is absolutely true in this situation. Okay. Now let's go to the next question. The sixth question. In the sixth question, we have given an equiconvex lens of radius r is equal to 1 by 6 meters having power p. Another biconvex lens of radius r1 and r2 is having same power p then. Okay. So p we can write is mu minus 1 to 1 upon r1 minus 1 upon r2. Right? Okay. So r1 and r2 are same because it is equiconvex. So that will be mu minus 1 upon r minus 1 upon r. So that will be like 2 times of mu minus 1 upon r. Okay, now r we have given is 1 by 6 meters. So if we put that value over here, then this comes out to be 12 into mu minus 1. So mu minus 1 comes out to be p by 12. Now another one p dash will be have the same power p for like mu minus 1 upon r1 minus 1 upon r2. So this we have given is p by 12, 1 upon r1 minus 1 upon r2 p. So this pp got cancelled it out. 12 comes out to be 1 upon r1 minus 1 upon r2. So this we have to check by putting all the options. So if we put a option, then this will be 1 upon 1 by 9 minus. This we have to take negative 1 upon 3. So that comes out to be 9 plus 3. So 12 comes out to be equals to 12. So A option satisfies this situation. So A option is absolutely correct in this situation. Okay. Now let's go to the next question. The next question, in the seventh one, we have given a real object placed in front of a spherical mirror forms an image whose magnification is minus 3. Minus 1 by 3. So if the distance between the image and object is 30 centimeter, the focal length of the mirror is. Okay. So that we can write is minus v by u. So v by u comes out to be 1 by 3, right? That is the one data we have given. And if the distance between the image and object is 30 centimeter, so the distance between image and object will be u minus u by 3, because from here you can write v is equals to u by 3. So if v is u by 3 and u is u, so the distance between them will be u minus u by 3. That we have given is 30. So 2u by 3 we have given is 30. So u comes out to be equals to 90 by 2, which is like 45 centimeter. Now we know that v is equals to uf upon u minus f. Okay, so v by u comes out to be f upon u minus f, right? So that we have given is 1 by 3, right? This we have given 1 by 3. So 3f comes out to be equals to u minus f. So 4f comes out to be u. So f will be u by 4. So that will be like 45 by 4. That will be 11.25 centimeter. That is its just magnitude. So focal length we have to write negative for this mirror. So that will be minus 11.25 centimeter. So A option is absolutely true in this situation. Okay, now let's go to the next question. Eighth question. In the eighth question, we have given in assertion the minimum kinetic energy required to take a body of mass m from surface of Earth to infinity is mgr. Okay, let's see that. So minimum kinetic energy will be half m. V escape square, right? So that will be like half m into it is like under root 2gr. So its square will be 2gr. So that will be like mgr. So that is absolutely true, right? It is given in the assertion. So assertion is true. Now let's go for the reason. Reason is potential energy at surface of Earth is 0. It is wrong because potential energy at surface of Earth is minus gmm upon r. So it is not 0. So reason is wrong. Assertion is correct. C option is absolutely true in this situation. Now let's go to the next question. The ninth question. In the ninth question, we are given an assertion. In photoelectric effect, if intensity of monochromatic light is increased, then stopping potential increases. See, stopping potential only depends on the kinetic energy, which is QB. So it doesn't depend on the intensity. So assertion is wrong. Assertion is absolutely wrong. Reason says increase intensity results in increment of photocurrent, which is absolutely true. Reason is true. So C option which says A is incorrect and R is correct is absolutely true. Okay. Now let's go to the next question. The 10th question. The 10th question, we have given two simple pendulums with amplitudes theta1 and theta2 have lengths of strings as L1 and L2 respectively. Choose the correct options. The maximum angular acceleration of them are same. So maximum angular acceleration of one is given as equals to alpha max of 2. Its formula we have is omega square theta. So omega 1 square theta 1 is equals to omega 2 square theta 2. Now omega we know it is 1 upon 2 pi under root g by L, right? Okay, so g will be same for both. So we can say it is inversely proportional to under root L. So this we can write theta 1 upon L1 is equals to theta 2 upon L2. So theta 1 L2 comes out to be equals to theta 2 L1. Theta 1 L2 is equals to theta 2 L1. So B option is absolutely true in this situation. Okay. Now let's go to the next question. The 11th question. In the 11th question, we have given a resonance tube experiment. It should be like closed at one end. Resonance is operated at two consecutive lengths. L1 is equals to 100 centimeter. That we can write is 1 meter. L2 we have given is 140 centimeter. That will be 1.4 meter. If the frequency of sound is 400 hertz, the velocity of sound is. Okay, so we know that distance between two consecutive resonances delta L is equals to lambda by 2, that we know. And delta L we can write is L2 minus L1. So that will be like 1.4 minus 1. That will be comes out to be 0.4 meter, right? Now lambda we can write 2 times of delta L. So that will be 2 into delta L we have is 0.4. So that will be 0.8 meter. Now we know that V is equals to F lambda. So frequency we have given is 400 hertz. So it will be 400 into 0.8. So V comes out to be 320 meter per second. V comes out to be 320 meter per second. So A option is absolutely true in this equation. Okay. Now let's go to the next question. The 12th question. In the 12th question, we have given a bulb rated 100 volt, 100 volt and 220 volt connected to an AC supply of 220 volt. Find peak current in the public. Find peak current in the bulb. So from your resistance, we can find out by V square. Sorry, P we know is V square by R. So yes, it is correct. V square by P. So V we have is 220 square by P we have is 100 volt, right? And I RMS, we can write V RMS upon R. So V RMS we have given is 220 upon R, which is 220 square upon 100. So this got cancelled it out. So that will be 100 by 220. So IRMS comes out to be approximately 0.45 ampere. That we can write I naught by root 2 as we have asked peak current. So I naught will be 0.45 into root. If you solve this, then you will get it approximately as 0.64 ampere. So B option is absolutely true in this situation. Got it? Now let's go to the next question. And the 13th question. The 13th question, we have given the torque experienced by a magnetic dipole in uniform magnetic field is 80 root 3 Newton per meter. Okay, so torque we can write is mp sin theta. Here we have given if the angle between the magnetic moment and the magnetic field is 60 degrees. So it is given 60 degrees. So mp sin 60 we have given is 80 root 3, right? And now we have to find potential energy. So U we know is minus mb cos theta. So theta we have given is 60. So that we have to calculate. So if we divide both of them, then MB got cancelled out. It becomes minus tan 60 and tan 60's value we know is root 3. So that will be 80 root 3 by U. So this root 3 cancel it out. U comes out to be minus 80 joule. So A option, which says minus 80 joule, is absolutely correct answer, right? Now let's go to the next question. The 14th question. In the 14th question, we have given a disk is performing pure rolling if speed of top point is 8 meter per second, find speed of point B. Okay. Okay. So A point has speed 8 meter per second. That we know. V plus omega, and in pure rolling, omega is same as that of V, so it will be like V plus V. So 2V we have got is 8, so V comes out to be 4 meter per second. Now we have to find out the speed of point B. It is at distance r by 2. So that will be like V plus omega r by 2. That will be like 4 plus omega r we have is 4 by 2. So that will be 6 meter per second. So speed of point B will be 6 meter per second. So C option is absolutely true in this case. Now let's go to the next question, the 15th question. In the 15th question, we have given a particle of mass m is at distance 3r from the center of Earth. Find minimum kinetic energy of particle to leave Earth. Okay, so kinetic energy, initial plus potential energy, we can write final kinetic energy plus final potential energy. That we can write. So kinetic energy initial we have to find out. That will be minus but initial potential energy will be minus gmm by 3r, because a distance from center is given as 3r. At infinity's final kinetic energy will be 0, final potential energy will be 0. Kinetic energy initial comes out to be gmm by 3r. Okay, so that we have to write in terms of the small g. So we can multiply this with r and r over here. So that comes out to be gm upon 3r square into m. So kinetic energy initial comes out to be mgr upon 3. Okay, so A option is absolutely true in this situation. Okay, now let's go to the next question. The 16th question. In the 16th question, we have given an AC source of 100 volt. VRMS we have given is 100 volt is connected to the given AC circuit. Find maximum current of the find maximum value of the current in the circuit. Okay, so IRMS we can write is VRMS upon SAT. So that will be VRMS we have given is 100 pi. Sorry, it was 100 pi volt. It was 100 pi. Upon Z we can write under R square plus XL square. Okay, so that will be 100 pi upon R we have given is 100 pi square plus XL we can write is omega L. Now omega we can write 2 pi F. So that will be like 2 pi. F we have is 50 and L we have is 1. It's a square. See, this both will become 100 pi square. So that we can write 100 pi upon 100 pi root 2. So that comes out to be 1 by root 2 ampere. As it is IRMS. So IRMS we know is I naught by root 2, the peak value of current upon root 2. So I naught comes out to be 1 ampere. Okay, so B option is absolutely correct in this situation. Okay, now let's go to the next question. In the next question, the 17th question, we have given a current carrying wire is in the form of a circle of radius r. Then we have to find the ratio of magnetic field at center to the magnetic field at axial point at a distance r from its center. So this ratio can be written as mu naught I by 2r upon mu naught ni r square upon 2r square plus x square to the power 3 by 2. So that will be mu naught I r square from 2. In place of x, we will put r because the distance we have given is r. This is the situation we have got. So this mu naught I and 2 got cancel it out. That will become 2r square to the power 3 by 2 upon r cube. So that comes out to be 2 root 2 r cube upon r cube. So the required ratio comes out to be 2 root 2. So B option is absolutely correct in this situation. Okay, now let's go to the next question. In the next question, the 18th question, we have given for a particle moving along a straight line, the displacement x depends on the time as x is equals to at cube plus bt square plus cd plus d. The ratio of its initial velocity to its initial acceleration depends on. Okay, so we can write is dx by dt. If you differentiate the above term, then this will be 3at square plus 2bt plus c. We have asked its initial value, so u will be the value of velocity at t is equal to 0. That comes out to be c. Acceleration will be d by dt, which comes out to be 680 plus 2b. Initial acceleration will be at t is equal to 0, so it will be 2b. The ratio of its initial velocity to its initial acceleration comes out to be c upon 2. So it will depend on the value of C and B. So B option is absolutely true. Okay, now let's go to the next question, the 19th question. 19th question, we have given a circuit. So we have asked the circuit diagram shown here corresponds to the which logic gate. Okay, so if we draw the all the possibilities or the truth table here, so this will be like 0, 0, 0, 1, 1, 0, 1, 1. So if we consider the possibilities, if we consider the OR gate, then this will be 0, 1, 1, 0. But if we see from the given circuit diagram, if we close the A and the B is also closed, then see 0, 0, 0. So this will be its bar will be 1. Its bar will be like 0. Sorry, that was 1. And its bar will be 0. Its bar will be 0. So the circuit turns on. The light goes to the LED when only both the switches are open. If they both are closed or one of them is closed, the current will not flow through there. So that is satisfied only in the NOR gate situation, right? So A option is absolutely true in this case. Okay. Now let's go to the next question. In the next question, we have given two cars get closer by 8 meters every second while traveling in the opposite direction. Okay, so their relative velocity when they are traveling in opposite direction will be VA plus VB, which is given as 8 meter per second. And they get closer by 0.8 meter every second while traveling in the same direction. So in the same direction, their relative velocity will be VA minus VB, which we have given 0.8 meter per second. So we have to calculate the value of V and PB. So if we add both of them, then 2 VA comes out to be 8 plus 0.8, that will be 8.8. So VA comes out to be 4.4 meter per second, right? VA will be 4.4 meter per second. And if we subtract both of them, then 2 VB, we will get uh, 2 VB, we will get 8 minus 0.8, that is uh, 7.2. So VB will be 3.6 meter per second in the case. That satisfies the B option. So B option is correct in this situation. Now let's go to the next question. The 21st question. The 21st question we have given. A particle is thrown with a speed u at an angle theta with the horizontal. When the particle makes an angle phi with the horizontal, its speed changes to p. Okay, so now we know that in projectile motion, the horizontal component of velocity always remains same. So that will be like u cos theta is equals to v cos phi, right? So from here, v we can write is u cos theta upon u cos theta upon cos phi. 1 upon cos phi we know is sec phi. So v comes out to be u cos theta sec phi. So C option is absolutely true in this situation. Okay. Now let's go to the next question. 22nd question. The 22nd question, we have given a ball weighing 10 gram. It's a hard surface vertically with a speed of 5 meter per second and rebounds with the same speed. The ball remains in contact with the surface for 0.01 second. The average force exerted by the surface on it. So F will be like delta P by delta T. As the ball rebounds with the same speed, so the change in momentum will be 2 mv upon the time. So mass we have given is 10 grams, so that will be like 10 upon 10 grams, so that will be like 10 upon 1000 kg. Speed we have given is 5 and time we have given is 0.01. So this got cancelled it out and F comes out to be 10 Newton, right? So B option is absolutely true in this situation. Okay. Now let's go to the next question, the 23rd question. In the 23rd question, we have asked about the blowing a soap bubble of radius 0.2 meter, given that the surface tension Ts of the solution is 16 to 10 to the power minus 3 Newton per meter. So surface energy we know is a surface tension into area, but here we have soap bubble, so we have to consider two surfaces, so it will be 2 TSA. So that will be like 2 TS into area we have is 4 pi r square. If you put all the values, then it will be 2 into 16. into 10 to the power minus 3 into 4 pi into 0.2 square. Okay, so that will be like 12 fours are 48 pi into 10 to the power minus 2 into 4 into 10 to the power minus 2. So that will be like 192 pi into 10 to the power minus 4 joule, right? So D option is absolutely true in this situation. Okay, now let's go to the next question. The 24th question. The 24th question, we have given a particle of mass and straight to light string and rotated with a speed v along the circular path of radius r. If T is the tension in the string and mg is the gravitational force on the particle, then the actual force is acting on the particle r. See, the actual forces in this situation will be mg and T only, because the net force towards the center is called centripetal force whose value is mv square by r, just like F is equals to m in the Newton's second law of motion. So mv square by r will be the net force towards the center. So here the actual forces are mg and T only. So A option will be correct in this situation. Okay. Now let's go to the next question. The 25th question. We have given under the action of a force a 2 kg body moves such that its position as a function of time is given by x is equals to t cube by 3. Okay, we have to find work done. So for work done, we can apply the work energy theorem, changing kinetic energy half m a square minus u square. Okay, so velocity we can write is dx by dt. So 1 by 3, it will be like 3d square. So that will be like t square. So we will be velocity at t is equals to 2. So that will be like 2 square. That will be 4 meter per second. And initial velocity u will be at t is equals to 0. That will be like 0. So work done comes out to be half mv square minus u square. So mv of v1 is 2 and v square will be 4 square minus 0. So work done comes out to be 16 joule, right? So C option is absolutely true in this situation. Okay. Now let's go to the next question, the 26th question. In the 26th question, we have given in a system of particles, internal forces can change. Okay, see, this is a theoretical question. We always have to learn that the internal forces can change the kinetic energy, but not the linear momentum. Linear momentum can only be changed by the external forces. So B option is absolutely true in this situation. Okay, now let's go to the next question, the 27th question. In the 27th question, we have given a collision occurs between two identical balls, each of mass m moving with velocities u1 and u2 collide head on. The coefficient of restitution is 0.5. The energy lost in the collision we have asked. Okay, so one thing we have we can apply the linear momentum will be conserved. So Pi will be equals to Pf means m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. And each equation we can apply. If we have given is 1 by 2, which is v2 minus v1 upon u1 minus u2. So kinetic energy lost will be like final kinetic energy minus initial kinetic energy. That will be half m1. Sorry, kinetic energy lost will be half m1. u1 is initial kinetic energy minus final kinetic. Half m1 u1 square plus half m2 u2 square minus half m1 v1 square plus half m2 v2 square. If you solve all this, then you will get delta K as 3m by 16 u1 minus u2 whole square. Okay, so D option is absolutely true in this situation. Okay, now let's go to the next question. The 28th question. In the 20th question, we have given a body of density. Rho is dropped from rest from a height h into a lake of density sigma, neglecting all dissipative effect, the acceleration of body while it is in the lake is. Okay, so if it is over in the lake, that will be like mg. And upthrust, if we consider the net force in upward direction, because the density of lake is greater than the density of body, net force will be in the upward direction, which is fph minus mg. That is equals to mass into acceleration. That we can write rho l into v into g minus mg to mn. So density of liquid we have given is sigma. V in we can write mass upon density of body, which is rho, we have given mg is equals to ma. So got cancel it out. Acceleration comes out to be g sigma upon rho minus 1, right? So that is in the upwards direction. Okay, so A option is absolutely correct in this situation. Okay, now let's go to the next question. 29th question. In the 29th question, we have given a block has been placed on an inclined plane with the slope angle theta. The block slides down the plane at constant speed. The coefficient of kinetic friction is equals to. Okay. So one is mg sine theta. Over here, one mg is acting on it in this. So mg sin theta and mg cos theta are the components of this mg only, and is kinetic friction acting on it. As it is moving with constant speed, so net force on it should be zero. So this force balances this. So mg sin theta should be equals to mu mg cos theta. So mg got cancelled out from here. Coefficient of kinetic friction comes out to be tan theta. Okay. So the option is absolutely true in this situation. Correct. Now let's go to the next question. The 30th question. The 30th question, we have got two rods, one hollow and other solid made of same material have the same length of 20 centimeter and radius of 2 centimeter. When their temperature increased to the same amount of 50 degrees centigrade, their expansion ratio is. Okay, so we know that their expansion will be like delta L is equals to FL upon A1, right? As both are made of same material, so Y will be same. Okay, both have the same length, both have the same radius, area will be same. Uh, the temperature is also increased to the same amount. Okay, so as all of them are same, delta L we can also apply L naught alpha delta T. So as initial length same, material same, so alpha same, delta T same. So expansion ratio will also be same. So EH on ES we can write 1 upon 1. Okay, so it only depends on the length. Okay, it doesn't depend whether it is hollow, whether it is solid. So 1 upon 1 means C option is absolutely true in this situation. Now let's go to the next question. The 31st question. The 31st question, we have given 5 grams steam at 100 degrees centigrade is passed into 6 grams of ice at 0 degrees centigrade. If the latent heats of steam and ice are 540 calorie per gram and 80 calorie per gram, and the final temperature is okay. So if we take, if we consider a heat required to convert all of the ice, that will be Q1 is equal to M into latent heat of fusion. That will be like 6 into latent heat of fusion. We know is 80 calorie per gram. That will be like 480 calories. And if we condense the steam, so that will be like M into LV. So that we have given 5 into LV, we have given 540. Okay, so that will be like 2700 calorie. And if we take the water from 100 degrees centigrade to 0 degrees centigrade, that way we have given ms delta T. So that will be like m into 1, sorry, m 5 into 1 into 100. So that will be like 500 calorie. So net heat absorbed will be Q2 plus Q3. That will be 2700 plus 500. So that will be 3200 calorie. So if all of the ice converted, the remaining heat would be 3200 minus 480. That will be 2720 calorie. So that heat will be used to raise the temperature of whole of the mass. So as complete ice melts, the total mass becomes 11 grams. So that will be like 11 into 1 into delta T. So delta T will be 2720 on 11. If you solve this, then you will get this value as 247 degrees centigrade approximately. So that is like greater than 100 degrees centigrade. At 100 degrees centigrade, we convert into steam. So the final answer will be 100 degrees centigrade because it is given more than 100 degrees centigrade. So D option will be correct. Now let's go to the next question, the 32nd question. The 32nd question. A gas takes part in two processes in which it is heated from the same initial state 1 to the same final temperature. The processes are shown on the PV diagram by the straight line 1, 2 and 1, 2, 3. 1, 2 and 1, 3. 2 and 3 are the points of this same isothermal curves. Q1 and Q2 are the heat transfer along with two process. Now, from the first law of thermodynamics, we know that delta Q will be equal to delta U plus delta W. As in the given situation, if you see the area, then work done in second situation will be greater than work done in one. So as delta Q is delta U plus delta W, say work done in two will be greater than work done in one. Delta Q in two will be greater than delta Q in one because delta U will be same in both processes because the final temperature and initial temperature are same in both the processes. So B option is absolutely true in this situation. Okay. Now let's go to the next question, the 33rd question. The 33rd question, we have given the RMS speed of hydrogen at 27 degrees centigrade is P. What will be the RMS speed of oxygen at 300 Kelvin? So VRMS, we know it is under root 3 RT by M. We can say it is directly proportional to under root T by M. So V1 by V2 we can write under root T1 by M into T2 by M. Sorry, T1 by M1 into M2 by T2. Okay. So T1 we have given is 27 degrees centigrade. If you convert this temperature into Kelvin, then this temperature will be 300. M1, the molar mass of hydrogen is 2, and to molar mass of oxygen we have is 32. So T2 we have also given 300, and V1 we have given is V. V2 we need to calculate. So under root 16 we have is 4. So V2 we will have V by 4. Okay. So D option which says V by 4 is absolutely true in this situation. Now let's go to the next question, the 34th question. The 34th question, we have given two balls of same material and finish have their diameter. The ratio 2:1. Both are heated to the same temperature and allowed to cool by the radiation rate of cooling of big ball as compared to the small one will be in the ratio. As we know that radius ratio and diameter ratio is same. So R1 by R2 we can write is 2 by 1. Now we know that rate of cooling is directly proportional to area upon mass. So instead of area, we can write 4 pi r square. And instead of mass, we can write density into volume. Volume we have is 4 by 3 pi r cube. As density remains same because the material remains same, we can say rate of cooling is inversely proportional to radius. Okay, so dt by dt of first upon dt by dt of second, that we can write R2 by R1. So that will be like 1 by 2. So B option is absolutely true in this situation. Okay. Now let's go to the next question, the 35th question. The 35th question, we have given two similar sonometer wires given fundamental frequency of 500 Hertz. These have same tensions. By what amount the tension will increased in one wire so that two wires produce 5 beats per second. Okay. So fundamental frequencies formula we know is sonometer wires 1 by 2L under root T by V. Okay, as the error is very less, so we can write delta F by F is equals to 1 by 2 delta T by T. And this is a rule we know. And for percentage change, this we can write, we can multiply 100 more on both sides. Okay. So the change in frequency we have is 5 beats per second, and the original frequency we have given 500. So that will be like 1 by 2 into delta T by T into 100. So percentage change in tension comes out to be 2%. Delta T by T into 100 we have got is 2%. So B option is absolutely true in this situation. Okay. Now let's go to the next question, the 36th question. The 36th question, we have given two rods of different materials having coefficients of thermal expansion alpha 1 and alpha 2 and Young's modulus y1 and y2 respectively are fixed between two rigid massive walls. The rods are heated such that they undergo the same increase in temperature. There is no bending of the rods. If alpha 1 is to alpha 2 is equal to 2 is to 3, the thermal stresses developed in the two rods are equal provided y1 is to y2 is equal to. Okay, so stress we know is y2 strain. So that will be like y alpha delta as stress on both of them are same. So y1 alpha 1 delta 2 delta t1 will be equals to y2 alpha 2 delta t2. As the change in temperature is same, so y1 is to y2 we can write is alpha 2 upon alpha 1 and alpha 2 upon alpha 1 we have given is 3 by 2. So C option which says 3 by 2 is absolutely true in this situation. Okay. So let's go to the next question, the 37th question. The 37th question, we have given the maximum kinetic energy of photoelectrons emitted from a surface when photons of energy 6 electron volt, force on it is 4 electron volt. The stopping potential voltage. Okay, so kinetic energy max we have given 4 electron volts. So that we can write charge into potential, stopping potential. The charge got cancelled out. Potential, stopping potential we have got is 4 volt. Okay, so B option is absolutely correct in this situation. Now let's go to the next question. The 30th question. The 30th question, we have given the circuit shown in the figure contains two diodes, each the forward resistance of 50 ohm and with infinite backward resistance. If the battery is of 6 volt, the current through the 100 ohm resistance is. So if we draw this circuit, so the situation will be something like this. This is the situation we have given. This is like 150 ohm. This is 50 ohm. And this is 100 ohm. This is 6 volt. And this is D1, this is D2. You can see the negative terminal of this is connected with positive terminal. So they both are in reverse bias. So current will not flow through this branch. As this is connected in forward bias, so current will flow only this branch. The resistance of this diode is given as 50 ohm. So I we can write V upon total resistance. So 6 upon total resistance will become 50 plus 150 plus 100. So that will become 6 upon 300. So that comes out to be 2 by 100. So I comes out to be 0.02 ampere. So B option is absolutely true in this situation. Now let's go to the next question. The 39th question. In the 39th question, we have given in a PN junction diode not connected to any circuit. Okay, so the potential is the same everywhere. Not is not correct. The p-type side is at higher potential than the n-type side. It is not correct because it is not connected to any circuit. The C option says there is an electric junction directed from n side to the p side is absolutely true. So C option is correct in this situation. Okay, we just have to directly learn here. Okay, now let's go to the next question, the 40th question. The 40th question, we have given a hydrogen atom and a lithium 2 plus ion are both in the second excited state if LH and L of Li at their respective electronic angular momentum and EH and ELi their respective energy. Okay, so we know that it is like if the situation like this we have given then LH will be equals to L of Li and the energy of the hydrogen atom will be greater than energy of energy of hydrogen atom will be less than the energy of the lithium atom. Its magnitude will be less. So B option satisfy this situation. Okay. Now let's go to the next question. The 41st question. 41st question, if x denotes the displacement time t and x we have is a cos t, a cos t, then we have asked to find out its acceleration. So we can write dx by dt. So that is like minus a sine t. Its differentiation will be minus sine theta. So acceleration we can write d by dt. That will be like minus a cos t. So B option which says minus a cos t is absolutely correct. Dot produce between this a and this a. This acceleration is A. Okay. Now let's go to the next question, the 42nd question. In the 42nd question, we have given in Young's double slit experiment intensity at a point is 1 by 4 of the maximum intensity. The angular position of this point is, okay, so I we know it is I naught cos square 5 by 2. Now I we have given 1 by 4 times of I naught. So this will be like I naught by 4 cos square 5 by 2. So this got cancelled out. Cos 5 by 2 we have got is 1 by 2. Okay, so 5 by 2 we have got is like 5 by 3. So 5 will be 2 pi by 3. Now we have a relation between path difference and phase difference. 5 by 2 we know it is delta x by lambda. So 2 pi by 3 upon 2 pi that we have is delta x upon lambda. Delta x path difference we have got is lambda by 3. That we know it is d sine theta. Path difference we know it is d sine theta. So from here, sine theta comes out to be lambda by 3d. So theta comes out to be sine inverse lambda upon 3d. This is its angular position. Sine inverse lambda upon 3d. The C option is absolutely true in this situation. Okay. Now let's go to the next question. The 43rd question. In the 43rd question, we have given a situation in which a parallel plate capacitor is of area 6 centimeters square at a separation 3 mm. We have given the gap is filled with three dielectric materials of equal thickness, see figure, with dielectric constant K1 10, K2 12, K3 14. The dielectric constant of the material which gave same capacitance when fully inserted in above capacitor would be. Okay. So this is the situation we have given. This is connected like this. K1 is 14, K2 is like 12, and K1 it is, sorry, K3 it is 10. Let's say this is T, 3 mm. If area, total area is A, then area of this part will be A by 3. Area of this part will be A by 3. Area of this part will be A by 3. We can see these both, all of the dielectrics are connected in parallel. In parallel, we know C equivalent is C1 plus C2 plus C3. C equivalent we can write K times of epsilon naught A by D. C1 we can write K1 times epsilon naught A by 3D, because area is 1 by third. That will be epsilon naught A by K2 epsilon naught A by 3 by D plus K3 epsilon naught A by 3 by D. Okay, so this thing got cancel it out in all of them. Okay, so K will be like K1 plus K2 plus K3 by 3. So that will be 14 plus 12 plus 10 by 3. So that will be 36 by 3. So K will be 12. So C option is absolutely true in this situation. Okay. Now let's go to the next question, the 44th question. In the 44th question, we have given the mutual inductance between a primary and a secondary circuit is 0.5 amperes. So M will be 0.5 Henry. So it is 0.5 Henry. The resistance of the primary and the secondary circuits are 20 ohm and 5 ohm respectively to generate a current of 0.4 Henry, 0.4 ampere in the secondary. Current in the primary must be changed at the rate of. Okay, so I2 we can write EMF upon R2. So EMF in 1 will be M di1 by dt upon R2. So M we have got is 0.5 and R2 we have 5. di1 by dt we have to calculate. I2 we have given is 0.4. Okay, so this will be 0.1 and di1 by dt we have got is 4 ampere per second that we have got. So A option is absolutely true in this situation. Okay. Now let's go to the next question, the 45th question. In the 45th question, we have given the least count of the main scale of a screw gauge is 1 mm, right? So that will be like 10 to the power minus 3 meter. The minimum number of divisions on its circular scale required to measure 5 micrometer diameter of a wire is, so which we know it is equals to least count, which is 10 to the power minus 3 meter. So instrument should measure, instrument should measure 5 micrometer, means 5 into 10 to the power minus 6 meter. It should measure this. So number of division will be pitch upon at least counts, which we have 10 to the power minus 3, and this will be 5 into 10 to the power minus 6 meter. So that comes out to be 200. Number of divisions should be 200. So B option, which says 200 meter, sorry, 200, number of divisions 200, it is absolutely true. Okay, thank you.